This is GT Physics 2 Lab 2 Charge Tapes Revisited by Ryan Perella, me. The purpose of this lab is to compare the electric force of a point charge model from Lab 1, which was the charge tapes lab, to a line charge model, as we will do in this Lab 2. Now, a line of charges, we will divide the tape into multiple line segments and treat each segment as a point charge. And we will use GlowScript in order to compute and simulate this example. We will use a computational model in order to simulate the tapes and the interaction force, and there is an image of what the lab looks like. A preview of the results. From Lab 1, the point charge on each tape was determined to be 1.167 times 10 to the negative 8th coulombs. And when we did the math with a line of charges, the charge on each tape was determined to be 2.37 times 10 to the negative 8th coulomb, so quite a significant difference. The fundamental principles used in this lab are the following. We have Newton's second law. A system's change in momentum is proportional to the net force applied. The formula we will use is F equals mass times acceleration. We also have Coulomb's law, which describes the force of attraction or repulsion between two electric charges. That is F equals K, which is a constant, times charge 1 times charge 2 divided by the radius squared. We'll use distance in this example. And the gravitational force describes the attraction between two objects with masses, which is Fg equals negative g, big M, little m, divided by radius squared. This is an image of the example for the lab. However, mine was inverse, so there was slack on the top tape, and then a tape was brought up to it, and it lifted up to raise the slack and have the force. Now, we're using the same experiment as Lab 1, where the tape mass was 2 times 10 to the negative 4th kilogram. The length was 0.2 meters, 20 centimeters. The width was 0.02 meters. And the distance between the tapes when they started levitating and holding each other up was 0.025 meters. Now, my results when doing this lab as a line of charges instead of point charges is my gravitational force, which is mass times gravity, is 1.962 times 10 to the negative 3rd Newton. That is the same as the electrical force, and that is because the tape is being suspended motionless in air, which means the force pulling the tape down has to be the same as the electric force pushing it up. So those are the same. And then when we simplify for Q in the electric charge formula, KQ squared, because they're the same charge, we're going to assume over distance squared, we get that Q equals 2.37 times 10 to the negative 8th coulomb. Finally, we get to the code. The first part is the same as last week, where I have my gravity, my K-value UFPES, and my measurements of the tape. This charge is the new one we calculated, 2.37 times 10 to the negative 8th. On the right side, you see the functions for the electric field. I did that by using my radius and then finding the magnitude and finding the R hat value, and then using the electric field formula to make my electric field function. And then through the starter code, I was given the line charge and how it iterated through and did that. So I was given that, and I did not mess with that. That's the function for the line. Well, I made my function for the electric field. Here is more of the code. We use superpositioning and nested for loops in order to create everything. And then for the making of the image, we use the force for the arrows, the force of the electric field in order to find the magnitude of the arrows, and then we printed out the answers. Here you can see the image that is produced. You can see that the gravitational force in yellow and the electric force in white are equal and opposite in sizes. They cancel out because the tape is held motionless. You can see the top tape being represented by those 30 red dots, the bottom tape by the same 30 blue dots. Those are all representing line charges. And then you can see the green fields, the green vectors coming off of every one of them. The assumptions made, same as last week, air resistance is negligible, friction is negligible. Each piece of tape has the same charge, and the charge on each tape is uniformly distributed. Some possible errors are measurements during the experiment, using a ruler is not the most precise instrument, and loss of charge due to handling the tapes and having our neutral hands affected. Now we can see that when modeling them as a point charge versus a line charge, we get a significant difference, 1.167 to the negative eighth versus 2.37 to the negative eighth. Why does this happen? Well, these estimates differ due to a different level and precision of the calculations. The line charge model is closer to the real value due to the fact that it uses smaller segments and we iterate through them along the tape's length instead of condensing the entire charge into a single midpoint. Thank you for watching.